All right. Good morning, everyone. Welcome to Comp 3350 Software Engineering. I hope that you all had a great weekend. I hope you had a great weekend. I hope you had a great weekend. It's like it feels like it's a really busy season. It feels like it's a really busy part of the season right now. I know that my 2150 class, they were feverishly trying to complete 2080, 2280, and 2150 all in 1 week. It was rough for them. I suspect that it's something similar for you, but except, you know, they're 3,000 level courses instead of 2,000 level courses. With that in mind, I'm sure you are aware, but the second iteration, the deadline for the release is this Friday. I published feedback for teams this morning on Learn. So there's team feedback for you on Learn right now. I haven't published individual scores for the assignments yet. I'm still working through the peer evaluation. So part of the peer evaluation, just to give you an idea of what's going on with that, I either get no feedback from a whole team, that's actually great because that usually means that thinks that everybody's working equally well. That's really good. Sometimes I get peer evaluation that merits further investigation on my part. So usually that means that I'm taking the time to look through the version control repository and kind of see what's going on there to get an idea of what kind of relative effort there has been. I don't usually like to look at version control repositories. Commits are not really a good measurement of how much effort somebody has put into something. But it's a piece of evidence and it's an indicator of the kind of effort that people have put into something. So if I'm getting some kind of feedback that says I should look further into this, I need to look further into it. But you should expect to get individual scores for the first iteration tomorrow. So by the end of the day tomorrow from me. I wanted to get the feedback for your team out as quickly as I could after I got feedback from the graders, and that's today. So please take a look at that when you get a chance. Like I said before, the smells that are in your repository, the issues that I personally created, those are your highest priority. If you haven't fixed those and you're still working on user stories, now is the time to switch to working on those and make sure that you have addressed the issues that I have put up on your repository. If you have any questions or concerns about those, come talk to me, please. Come talk to me so I can give you feedback or a little bit more direction about what to do. Today, we're going to spend some time talking about testing. We're going to spend some time talking about testing and test doubles. So that's the only topic that we have today is test doubles. On Thursday's class, we're going to be spending time talking a little bit more about project management related stuff. So one of the things that you can measure, give you a preview here, one of the things that you can measure about your work that you've been doing on a project is something called velocity, which is approximately how much work you're able to get done in a specific unit of time. So we're going to take a look at how we can measure that and then how we can make changes based on the velocity that we've got. But today we're going to be focusing on test doubles. So first things first, test doubles. When we were talking about unit testing, and when you have been talking about unit testing, going all the way back to like Comp 2160 and Comp 2150, if you talked about unit testing there, the goal of unit testing is that you're testing units, right? Very small parts of your application, but you're trying to test those units in isolation. Test doubles are meant to replace dependencies that the units that you're trying to test have. I want to put this in the context of the architecture that we have been working with. Here's our 3-tier architecture, our N-tier architecture. We've got that data model that fits on top of everything, and then we've got 3 layers for the application itself. We've got a presentation layer that has all of our Android-specific code. We've got a logic layer, and we've got a persistence layer. The unit tests that we're writing for this course, and then kind of generally the unit tests that you would be writing for projects like this, belong either in the data model, so evaluating the behavior that's part of the data model that you've got, or testing the logic layer. The logic layer has dependencies. The logic layer has a dependency. So any of the classes that you have that are of the form, I don't know, they end with something called service.java or something like logic.java. Any of these classes, so any of these literal classes that you have some dependency on the persistence layer. So they call methods, they go past the seam to get data from the persistence layer, and the persistence layer sends something back based on what's in the database or based on what's in memory right now. This dependency that you have between a logic layer and a persistence layer, you are now hopefully all in the state of trying to change and successfully changing from using stub implementations to using a relational database, so HSQLDB. When we're going through the process of unit testing, we don't want our logic layer to be unit tested using HSQLDB as a dependency. We don't want that. What we want to accomplish is isolating the behavior in the unit that we're testing entirely by itself. We want to replace the dependencies that we have with something that's not going to affect how the test works, or alternatively, we want to replace that dependency with something that lets us specify how that dependency works. Test doubles, test double, this term that describes this broad class of things, are implementations of dependencies that replace those dependencies in the system that you're trying to test at any given time. This link, there are many different kinds of test doubles. This is one of the readings that I put up for you. This XUnit patterns website it's fine. It's kind of old looking. I'll fully admit it. It's kind of old looking, like it was made in 1996, but it's good. It's got good information in it. There are lots of different kinds of test doubles. There are a lot of different kinds of test doubles out there. The ones that we are primarily interested in this course, what is going on? Oh, you know what that is? It's like where the keyboard and mouse and stuff is. Thank you. I would never have noticed that if I didn't point it out. The ones that we're most interested in are fakes, stubs, and mocks. And one of those words you have seen before a bunch of different times. That one word that you've already seen before is that one. You've seen this word stub a bunch of times, at least in the sample project, in terms of the persistence layer that was there initially before it got translated into using HSQLDB. I'm going to just describe to you what these things are. So like a plain English definition of what this thing is. I'm going to show you a simplified code sample that demonstrates that kind of test double. And then after that, we're going to have just a short little quiz about these test doubles. So a stub is a test double that is a partial or full re-implementation of a dependency. The dependencies that we're talking about here are the interfaces for the persistence layer. So in our specific case, the dependencies that our logic layer have are the interfaces that we've defined for our persistence layer. A stub is a partial or a full implementation of that dependency. So a partial or a full implementation of that interface. When we're thinking about types and subtypes, this is something that may not satisfy the Liskov substitution principle. So remember solid design principles, the L Liskov substitution principle. What this is saying is, if we have types, a supertype and a subtype, we should be able to replace instances of the supertype with its subtype and not have to change any of the surrounding code. We should expect it to behave the same way. A full implementation of a dependency may satisfy Liskov. A partial may not satisfy Liskov. Stubs, when we're creating these classes, will give responses back. So you're calling methods on the dependency. It's a test double. You're replacing that implementation with a test double. Your logic layer will make calls to that. And then what the implementation that you've written that is the stub will do is send back test-specific data. So let's take a look at a piece of code. There's a bunch of stuff here, but I want to work through it together to make sure that we all see what this is looking like. We've got a class here called logic. This is in the middle of our n-tier architecture. This is the logic layer. This is our implementation of some kind of logic layer thing. We have an interface defined for the persistence layer. And the implementation of that dependency in the logic layer is injected. So we're using dependency injection in this example. The logic layer depends only on the interface and not on any specific implementation of the persistence layer. There's a single method that I want to test in this logic layer class. This uses some stuff that, I don't know, maybe you've seen and maybe you haven't seen before. So using some of the functional features of Java. What it actually does is kind of irrelevant. The only thing that's really important that we care about right now for this example is that this method that we're trying to test interacts with the dependency. So we're calling methods on the interface that is the dependency that we have in this logic layer class. We've got a test class here. This is going to be the suite of unit tests for this logic layer component that we're trying to work with. The test that we're writing here is going to be, I want to make sure that when the dependency returns an empty list, that my function or my method still works the way it's supposed to work. So I'm not going to get like a null pointer exception. That would be unexpected in this case. We create a stub implementation of our interface by creating a new instance of an interface. This is probably something you've never done before. Probably something you've never done before. Has anybody made a new instance of an interface? Just out of curiosity. One person, co-op? Oh, cool. Okay, cool. This is so for most of you, this is something that you've never done before, but this is something that you can do in Java. You can call a constructor on an interface by providing a full implementation of that class immediately after that. This is a stub. It's a test double because we're replacing or injecting into the system that we're testing right now. The system we're testing is this logic layer. We're injecting a test-specific implementation of this class. It's test-specific here because we are returning an empty list. So when we call this dependencies method, we're just returning that empty list. We're specifying what the data is in the test itself for how this thing should work. We create an instance of that thing that we're testing, and we inject that implementation into it. And then we call the method. So here we're just going to like do something. We're passing a method reference to be applied to all these different things that get returned from this object. We don't care that much about the actual thing that this logic layer thing does. The only thing that we really care about in terms of this test double is a stub is that it's returning a test-specific piece of information. I would rewrite this test copy paste it, and I would add, instead of return new array list, I would say return some other list that's filled with stuff to test regular happy path behavior of this implementation. Okay with stub? This is very specifically the implementation that we provided here returns an test-specific data for the test that we're running right now, or the test that we're writing right now. A fake is a full implementation of a dependency. So you've got this interface that's been defined as part of your dependency. A fake implementation is a complete functional implementation of that interface. The responses that it sends back, the messages that you can send to this dependency, to this fake, they all work approximately the same way as the actual implementation, the actual dependency that you would expect to use. Because it behaves similarly to what you've got as your real dependency, this should satisfy Liskov substitution principle. I should, be able to make changes. I should be able to inject this fake dependency and not have to change anything about the code that I've written. We've got the same kind of setup here. We've got a database that's our persistence layer. This is the thing that we're depending on. Instead of having a new instance of an interface, I've got a full class implementation. The class implements this interface. The real data layer for this example that I've got here does some kind of persistence with SQL, a relational database. But this one just uses an array list, and it operates on that array list as though it were some kind of in-memory store. Similar to the last case, we inject that fake implementation into the thing that we're testing in the test itself. So we create an instance of the fake, we inject it into the logic thing that we're testing, and then we run a test on that. So we expect that fake to behave approximately the same as the real dependency that we have, but it's not actually doing the real thing that we have as a dependency. So there's no like SQL or anything in this. Okay with this? Good, 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 good. A mock, this is the last kind of thing that we want to evaluate here. A mock is a partial, and I'm going to put in scare quotes here, implementation of a dependency. The difference between stubs and fakes and mocks is that a stub and a fake are verifying the unit itself, verifying the behavior of the unit itself that we're testing. And a mock's goal is not to verify the behavior of the unit itself, but rather the interactions with the dependency. These are two different things. With a fake and a stub, our goal is purely to evaluate the behavior of our logic layer classes without having a real dependency, without using relational database and persistence that way. With a mock, our goal is not evaluate the behavior, not so much evaluate the behavior of that thing that we're testing, but rather verify that when we make calls to this class, that the interactions with its dependency are satisfied, that it does specific things when we make calls to it. Okay. We've got our interface, we've got our persistence layer, our database. We're implementing another class here that does implement that interface. So we should be able to inject it into the logic layer thing that we're trying to test. The goal with a mock is that we're trying to evaluate the interactions between the system that we're testing and its dependency. There's a property here that's called wasGetThingsCalled. It's a Boolean, so true or false. We have the thing that this mock object should respond with. So we're telling this mock object, this is what you should return when a certain method is called. We've got a constructor that just accepts an instance of that list that we will send back. And then we have unimplementation of the interface. When this method is called on this mock implementation, we change that property. This method was actually invoked by the test that was just run. And then we return the thing that we were given in the first place. So we were provided with this list of things to send back as a response. Let's send back those things. In the test, I am now no longer verifying the behavior of the object itself. I don't care about what that object did or that it works. That's a separate test. Here, I'm creating an instance of this database mock object, and I inject that into my logic layer. I still call the method that I want to evaluate. I still call that method because I need it to run through whatever it's supposed to do with that thing. And the assertion that I'm making here now is not, does this method work? But instead, did this method try to call the dependency in specific ways? Did it call certain methods as opposed to, did it actually do the job that it was supposed to do? So unit tests that are stubs and fakes are implementing this in isolation, completely in isolation. A unit test that includes a mock is now starting to evaluate this part. It's starting to evaluate the interactions between two layers. This is beginning to approach integration testing. So integration testing, remember, is we want to see whether or not this layer and this layer are interacting with each other appropriately. I want to send some data to my database and then get it back and verify that it was actually persisted. A mock implementation is beginning to approach that. I want to verify that my logic layer interacted with the persistence layer, but I don't actually care if it persisted anything. There isn't an implementation for that. I don't care if it persisted anything. I just want to know that it tried to do that, that it made an effort or made that method call. We okay with that? We're good? We're good? We're good? Okay. Yes?
So all these blocks and fakes and whatever, do they all live alongside the tests or the actual?
So yeah, that's a great question. Where do these live? They're not part of your domain model because they're related to the classes. They don't live in your presentation layer because they're not part of presentation. They don't live in the persistence layer. They could live in the persistence layer because they are implementations of the persistence layer. But because it's just for testing, they belong in the test folder, the test subfolder. I don't know what that's called. It's not a package. It's like a separate code folder. I don't know. But it doesn't belong in the persistence package in the main app folder. It belongs in the persistence package in the test subfolder. Yeah, okay. The reality of mocks, though, is that you are not going to do this. Writing that out would be really painful, especially if you have 10 methods on your persistence layer and you want to verify complex interactions between the logic layer and persistence layer. Usually, you're going to use a library to do this, as opposed to writing your own mock implementations. So Mockito is a library that you can use to implement mocks and use mocks in a testing suite. This changes drastically the implementation that we have here. We still have that persistence layer interface. We still have a test class, and we still have that logic layer. But we don't implement a class that actually does all of that stuff. We don't implement this interface anymore. Mockito is going to give you methods like mock here. And what mock does is it takes as an argument the name of the interface that you want to mock, that you want to create a mock for. Mockito then goes through a lot of like Java reflection stuff to build an implementation of this interface. There's magic. Magic happens, and what comes back, what gets returned by this method is an implementation of that interface that you provided to it. The implementation that you get back from this is an instance of this interface. It's an instance of this interface, so you can inject it into your logic layer as though it is an actual thing that your logic layer depends on. You can do things like say, I want you to return this when this method is called. You can test the thing that you're testing, and then you can verify. So this verify is another method that comes from Mockito. You pass it the thing that it created, the instance of your interface that it created. And this verify is like an assertion. This is saying assert that this method was called on this instance of that, that persistence layer class. Don't do this, like don't write your own mock implementations. Stubs and fakes, you kind of have to write your own implementations of those, but mocks, you don't have to do that. Mocks and stubs and fakes are all kind of interrelated with each other in the sense that you can create stubs using a mocking library. So you can create a stub implementation, so something that returns test-specific data using a mocking library as opposed to making new instances of this interface all the time. Okay, let's do a little quiz. I'd like to do this as teams, so pick somebody to be the device holder for your team.
I'm not surviving.
Okay, so the game pin should stay up if you haven't quite joined yet. But let's get started. Okay, good. The main difference between a mock and a stub is that a mock can be used to verify interactions with a dependency. As it's defined, a stub does not give you that functionality. We could argue that you could do that with a stub implementation if you want to, but mocking specifically is about verifying interactions with a dependency. This is true. This is a true statement. A stub returns predefined data. That is a true statement. And you can get a mocking library to do stubbing for you. You can build a mock called mock with Mockito and then say when this method is called, return this, instead of writing that class yourself. But because you can do that with a mock, just because this is true doesn't make it kind of fully true. Mocks and stubs are the same thing. Again, we could argue that that's a true statement because we can use one or the other to make the other, but the most correct answer here is Stubbing is very much not giving you the ability to do verification of interactions between classes. Runtime terror. I'm trying to decide if I should bring back those pieces of paper that I put on the table. There's just a little bit of whimsy in the class. Okay. This is referring to the sample project specifically. Okay. All right. Okay. 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 Crying out loud. One day, I will be fully logged into all systems before I come to class so that you don't have to see my password manager. So I want to provide you with some more context here. So I'm going through the sample project right now. And actually, I'm going to take a step back here. I'm going to go to tags, and I'm going to go to iteration 1. I'm going to go to iteration 1 because this is the place where we still use those persistence layer classes that are called stub in the persistence layer. So there's a package here that's called stubs. Here's course persistence stub. This course persistence stub implements the interface that we have for the persistence layer. So we implement course persistence. It internally has a list that we populate with data. So it's an in-memory storage something, in-memory implementation of this persistence layer. And this implements all methods that are defined on that interface. Yes, but why bother fixing it now? That's a correct answer. I should have put that one correct. I'm sorry. No, I'm not sorry. No. Yes, this is the wrong convention to use. This is the wrong convention to use for what we're using these things for. Why bother fixing it now? I should fix it. I should fix it. No stub makes the most sense. Our definition of stub is that it's an implementation of a dependency that returns test-specific data. Test-specific data. This implementation does not return test-specific data. There's data in here, but it does not return test-specific data. This is just an implementation that has its own list to keep track of things. This is better described as a fake. This is better described as a fake because it implements the entire interface and it behaves the same way as the real dependency, or at least as close as possible to what the real dependency should be. So stub doesn't make sense very specifically because it's not returning test-specific data. We're not changing what it returns for each time we run a new test in this thing. Is that okay? We're good? Good, good. Front row. Okay. Okay. Good. So this is now a throwback to quite a long time ago. This is a throwback to like Comp 2160. So again, sorry, I don't know who you took Comp 2160 with, but one of the things that ideally you should be getting as an outcome from that course is to be able to distinguish black box and white box testing. We recovered that in this course. We did recover that in this course to make sure that we're all on the same page. Black box testing is where we do not know what the implementation details are. We're testing an interface. The thing that we are testing is our logic layer. That is our system under test. Our system under test is our logic layer. With black box testing, we don't know how methods in that class are implemented. We don't know. Verifying interactions between the logic layer and its dependency using a mock. So this part right here, verifying those interactions requires that we know how it's implemented. We have to know how it's implemented to decide whether or not certain methods in the persistence layer have been called. We have to know how it's done. Otherwise, we're just guessing. Well, maybe it calls this and maybe it doesn't. I don't know, but that doesn't really make a lot of sense. We have to know how it's implemented, the system that we're testing, to be able to decide whether or not it has interacted properly with the dependency that we've got. So verifying the interactions between these two layers is most closely attached to white or clear box testing because we can see the implementation. We have to see the implementation to know how it interacts with its dependency to be able to verify that it has interacted with its dependency. You could do black box testing, but again, you're kind of in the state of like trying to guess what methods it's calling to interact with its dependency, and it doesn't make a lot of sense to do that. Blue box testing is, I don't know, like take your machine and just chuck it in the bin. I don't know. Is that okay? We're good with that? Okay, good. G1 is coming for you, front row. Actually, they're both in the front row. Okay. All right, so I'm sorry. This was intentionally confusingly worded. This was very intentionally confusingly worded. The main reason to use a test double is not to isolate the test double. We're not trying to isolate the test double from anything. The test double is its own thing. Test doubles don't depend on anything. They don't really depend on anything because we're using test doubles to replace the dependencies of the thing that we're trying to test. So the main goal here is to isolate units for testing. Okay, all right. Stack Overflow is moving up here. Here's the last question. These are both correct. These are both correct. So I'm delighted to see that it was split fairly evenly between the two of them. Mocks and stubs. Okay, so stub, we have an implementation of our dependency that returns test-specific data. Test-specific data. Mocks are giving us the ability to verify interactions between the system that we're testing and its dependency. Mocking libraries can do the same thing as what a stub does. You can set up a mocking library to say, when this method is invoked on this object that you have created, please return this specific data. We could implement a mock with a stub by having all that ridiculous tooling ourselves, a bunch of Booleans that say, did this method get called or not? We could have a bunch of data that we inject into the constructor. When this method is called, return this specific thing for this specific method. You can implement a stub with a mocking library, and you can implement a mock with a stub. You can do verification of interactions with a stub implementation itself. Oh, I think I know what this means. Hey, front row. Okay. I'm actually going to skip this. I'm going to skip this. I feel like we have fully established what the relationship between these different kinds of test doubles are. If you want to talk about this with your team independently, you are more than welcome, but I can't see any of you doing that. If you want to do that, please go ahead. But I'm going to skip this activity just because I want to get on to something else. The tools that you would use to implement each of these different kinds of test doubles for fakes is just write it out. Write it out. Just write it out. It's a class. Just write out your class. Provide your own implementation of it. Use the language that you're using. You don't need any special tooling to do that. A stub implementation, just use your language. Just use your language. Whatever language you're using to write this, just do whatever you want to do. Or alternatively, follow the same approach as mocking library, so use a mocking library. For mocking, the one that I'm going to strongly recommend that you use, there are several different mocking libraries that you can choose from, but the one that I'm going to recommend that you use is Mockito. It's really straightforward to use. You can add this as a dependency to your project in the Gradle properties file, and you'll have it as part of the testing stuff. Using Mockito is really straightforward. So I'm going to pop this link open because I think it's worth taking a look at. It tells you everything that you need to do here. And they make really lame puns about drinking a drink. So adding it as a dependency to your Gradle file and then actually verifying that things are done the way that you want to do it. It's really easy to use. It's really, really straightforward to use. And stub method calls and here. So this is giving you an idea of how to use this to do stubs. You've got your mocked thing. You use this when method. You pass it the interaction that is going to happen. So in this specific case, this is saying when that method get is called with this specific argument of 0, return this specific thing. So you can implement stubbing with this mocking library. And in Python, you can use unit test.mock. It's just kind of part of the language. This is something that comes in the standard library for the language. All right. So to summarize, well, let's all look at our watches. Let's summarize. I want you to now, oh gosh, you should be able to now explain the purpose of test doubles in testing. You should be able to do that. I should be able to ask you that in a test. I should be able to ask you that in a test, and you should be able to do it. You should be able to compare and contrast stubs, mocks, and fakes. And you should be able to write isolated unit tests using test doubles. So not necessarily mock dependencies, but using any kind of test doubles. The release for iteration 2 is Friday of this week. And what I want to use the rest of this time for, we have about 25 minutes left of class time, is I would like to, as much as possible, visit each team that's here. So please don't leave before I've come to talk to you. But I want to make sure that everybody is able to succeed with getting the relational database stuff set up. That's what I'm planning to use the rest of this time for. You should use this time to work on your project. You've got 25 minutes to do it. Maybe that's having a meeting with your team. Maybe that is actually writing some code. But please don't leave before I talk to you, OK? OK, thank you all.
Yeah.